Let's talk about 0. As far as numbers go, 0 is pretty far out there with its weird properties. We've all heard that you can't divide by 0 in general, which is a very strange restriction, and I've also personally wondered about what it means to have 0 as an exponent or how you could possibly ever know what 0 factorial is. To answer these questions, I'm gonna have to go back a bit and discuss numbers. In a very, very simple and non-philosophical sense, numbers are tools for counting and describing relationships. If, out of boredom, you wanted to count how many cows you have, you line them up and begin counting with an established system. I have 1, 2, 3, 4, however many cows. Fractions can be symbolized by partial cows. Well, what happens if you're short on money and have to sell all your cows? How could you describe the nothingness of cows before you? As a result of your ingenuity, you create or find a new number, depending on if you want to have a philosophical fight or not, which you call 0. So, you had all your cows, and unfortunately, now they're all gone, and now you have 0 cows. In other words, 0 is equal to cows minus cows, and to generalize, a minus a is equal to 0, where a can be any quantity at all. Obviously, this also works for negative numbers, where if you have cow debt and then pay it off, you have 0 cow debt. This brings me to my next point. Basically, cows multiplied by 0 is equal to 0, and to generalize, a times 0 is also equal to 0. A loose definition of multiplication is repeated addition. So, a times 2 means that you added or brought in 2 a's. If you multiply a by 0, that means you never had it in the first place and have 0 as a result. If this explanation is still a bit confusing, I would recommend saying 0 times a out loud. The expression itself means that the amount of times that you had a is 0. You never had any at all. We can generate two instances of this equation where a is equal to different quantities. Dividing both sides of the equation by 0 gives us the following, and there you have it. We have proved that 1 is equal to 2. At this point, you have two options. You can either accept that the entirety of math is broken, which is fine, you're free to do that, or we can put a restriction on dividing by 0, which is what most mathematicians tend to do. A similar example involves the function 1 over x. We can describe the behavior at x equals 0 using limits. If the value of x approaches 0 from the negatives, then the function tends to negative infinity. Meanwhile, if x approaches 0 from the positives, then the function tends to positive infinity. Clearly, these limits do not equal each other, so the limit as x approaches 0 just does not exist. To delve deeper and gain more insight, I would investigate the general function a over x in your free time. So to reiterate, and most importantly, we do not divide by 0. Exponentiation is actually a lot simpler to explain. You can just take any number and raise it to the power of 0. As we learned from before, 0 can be expressed as cows minus cows, or similarly, a minus a. The quotient rule of exponentiation says that this expression is equivalent to the following, and as a result, we have some quantity divided by itself, which, as we know, is equal to 1. And when the quantity equals 0, this obviously doesn't work, because as we said, we just do not divide by 0. So anything to the power of 0 is equal to 1, except 0 to the power of 0. This brings us to what I think is the most interesting question, which is what is 0 factorial? The factorial function takes some positive integer and spews out the product of all positive integers smaller than or equal to it. We can also say that some integer factorial is equal to that integer times the integer minus 1 factorial. Since we are interested in 0 factorial, we'll just plug in 1. This gives us 1 is equal to 0 factorial times 1. Therefore, 0 factorial must equal 1 to satisfy that equation. An even cooler explanation of the same thing involves the gamma function, the analytical continuation of the factorial function. All you really gotta know is that this function has less domain limitations and that it matches all factorial outputs. The functional equation says that the gamma of n is equal to n minus 1 factorial. This is the bridge we can use to find what 0 factorial is. Again, we are interested in 0 factorial, so we plug in 1 for n. When we plug in 1, the integral becomes super simple, and as we solve, we also get to use 0 as an exponent like we discussed before, and everything ties together, and you get 0 factorial is equal to 1. And there you have it. 0 works in some mysterious ways, but it's really a non-issue. Thank you guys so much for checking out my second ever animation that took an incredibly long time to make. There's some goodies in the description for you guys to check out. There's the song, and there's some other Wikipedia links about the gamma function and other stuff that I couldn't cover in this video because that is a incredible amount of content. I also want to say that in about a week I'm heading off to college, so I don't know when the next video is going to be out. I don't know what the workload is going to be like. I don't know how much time I'll have to animate, so I just don't know. But there will be videos coming in the future, so stick around, subscribe to know when these come out, because again, they take a long time and you want to be subscribed to be notified. And I'll see you guys on the next one.